Afternoon. My name is Mark Stewart. I'm the director of the RSK Geosciences business. I'd like to welcome you to our second Down to Earth webinar, which today is on service avoidance during site investigation. And we've had well over 250 people register for this, so it's obviously quite a popular topic. So before we start, I'm just going to run through some brief housekeeping notes. So just so you know, all attendees' microphones are automatically muted throughout the webinar. During the presentation, you can post questions and we'll have a question and answer session at the end of the presentation. We'll answer as many as we can, but if we can't, then we'll get back to you via email or telephone call and make sure we answer all the questions that we receive. And shortly after the webinar, you'll receive a link to a short survey. So if you could take a few minutes to provide any feedback for future webinars, that'd be much appreciated. So without further ado, I'd like to introduce Gerwyn Leigh, who's going to be presenting to us this afternoon. Gerwyn is an Associate Technical Director for RSK Geosciences and heads up our SafeGround, which is the utility and mapping arm of our geophysics team within RSK Geosciences. Gerwyn has an MSc in Applied Geophysics from the University of Birmingham and 17 years experience in undertaking Gpr utility and geophysics surveys. He's also a chartered scientist through the Geological Society. Gerwyn is a qualified EML trainer on cat and Jenny and radio detection equipment and provides service avoidance training to RSK staff, not only in geosciences, but also our sister companies, in Structural Soils, Ian Farmer Associates, RSK Response, ADAS, and the Structures and Materials business. He's also written several technical procedures for RSK, including our own in-house technical procedure on avoiding services during site investigation. So over to Gerwyn.
Thank you very much, Mark. Hello, everyone. I'll just turn off my webcam and then we can begin. Thank you. So today I'm going to talk to you about PAS128 and buried service avoidance, especially with the decisions that should be made before progressing with site investigation and how it fits in with HSG 47 and the permit to dig system that we have within RSK and its relationship to BS 5930. I'm also going to talk about the upcoming revision to PAS128 that hopefully is coming out later this year. So what was the motivation for a British standard with utility surveying? Well, the need came out because of the danger from buried services and the number of strikes that occurred when breaking ground. There was and is a reliance on service plans. Service record plans produced by statutory service providers only show the assets they own, so they won't include private services, so things like feeds to people's properties. And as you can see from these statistics, there's a large number of incidents that did review plans that hit services that weren't shown, and that many of the service strikes reported the location shown on the service plans to be inaccurate. So safety is the clear driver here. In this, buried utilities are going to be one of the highest, if not the highest risk to health and safety when breaking ground with site investigations, especially with safety critical services such as gas and electricity being present. But there is also going to be a cost implication. Now, as you can see, the average cost of service strikes is significant, and the strike to cost ratio is also pretty high. And these are just the average costs. We've heard of a fibre optic cable strike that ran into the hundreds of thousands because of the length of the cables that needed to be replaced and the complexity of the environments that those cables ran through. Prior to PAS128, in one site investigation, these cables were exposed even after a developer had commissioned a Gpr survey of the area. Gpr had supposedly been done across this area, but the cables weren't picked up or shown on any of the deliverables. The client went back to the practitioner, who said that the area was not conducive for GPR, so it didn't work. But there was no proof that the GPR was even done. There was no data that had been recorded. So as such, the client couldn't do anything about it. They had no comeback. So why were these big bank of cables missed? We're going to look at this small case study here. So after multiple service strikes during the site works on a flood risk alleviation scheme in Wiltshire, after a survey by Company A, Company B were commissioned by the Environment Agency to undertake the resurveying of buried services along the same survey area. Now, the top figure there was the Company B survey, the resurveyed survey, and below is where we've highlighted the differences between that survey and Company A's survey. And as you can see, there are quite a few. But why? If a company has asked for a GPR survey, why were there so many differences between those two surveys? Well, if we have a look at one of those differences shown here, Company A indicated that that area was too muddy or narrow for accurate GPR, so GPR wouldn't work. Nothing was shown on the drawing as being detected there, and a trial hole had been dug, and that trial hole had a refusal as it hit a solid obstruction. When Company B acquired the GPR data, and they located a reinforced concrete culvert. So clearly the GPR was deployed and worked. PAS128 was created in 2014 and aimed really to help clients navigating through obtaining a utility survey and protecting themselves from poor results which lead to service strikes. It aims to provide consistency of data capture to ensure deliverables are recognizable and there's accountability in the results. And it sets about providing clear survey types and provides the accuracies that the results that clients should expect when commissioning those buried services surveys. And those survey types were split into those 4 categories, with type D, the collection of the desktop utility drawings, being the lowest accuracy or lowest quality, all the way up to the highest quality and accuracy of survey type A verification. And in between there, you've got the type C site reconnaissance survey, where you'd walk the site with a copy of the desktop utility records and note any similarities and differences. And then the type B survey, the detection survey, where you'd actually go out and trace and map those utilities. Whatever level has been carried out, PAS128 requires the practitioner to state the accuracy levels of each of the segments of the utilities identified, as well as the detection techniques used, even when no utilities have been detected at all. And we're talking certainly for the verification survey, the highest quality level, we're talking about really high accuracies here. And this is where the service has been visually confirmed, either through exposure in an excavation, as per that picture there, or in a service cover when opening them up in order to locate services. And as you can see, the accuracies are very high. We're looking at 25 millimeters vertically, 50 millimeters horizontally, as these are topographically recorded positions of the exposed services, or they are measured from the cover that has been opened to access the services. Quality level B surveys are complicated. They're the most complicated of the PAS, as it's the most complicated part of utility mapping. For a quality level B survey, PAS128 requires 2 or more geophysical techniques to be deployed to detect and identify services. And these are most commonly GPR and EML, electromagnetic location. The practitioner is required to state the quality level that they've identified each segment of each utility they've traced at these levels, and those levels are B1 down to B4. And if post-processing of GPR data is used to achieve a more thorough and complete interpretation, these quality levels can be suffixed with the letter P. So this table in PAS shows the increasing quality levels and therefore the increasing accuracies. It's a requirement of a Type B survey to have a desk-based services search of utility records. And as part of the detection survey, a site walkover is undertaken either initially or prior to the survey commencing. So therefore, if a Type B survey is commissioned, the Type D and Type C surveys will automatically be done as part of that survey. And the highest level of accuracy for a Type B is a B1. And you can only attribute a B1 quality level if the utility has been detected in 2 or more geophysical techniques and the practitioners deem that the accuracies from the GPR are high enough to assign that quality level. And the additional P can be attributed to B1 to B3, indicating that additional detail has been obtained through the post-processing of the data. And post-processing is good. Ps are a good thing. GPR data is complicated and it's very difficult to try and interpret complex GPR when on site. On site with GPR, you're provided with real-time data of the scan you're undertaking, which is great for immediate information. But if you're on a busy site, there's multiple services, so especially urban areas, brownfield sites, places that have been redeveloped, places with buried obstructions, things that have been filled in the past, it's not possible to undertake a thorough interpretation. So post-processing is absolutely essential in order to do this. So I'm going to take you through a case study now, and this is of a site in Sunbury-upon-Thames where the client was redeveloping this open ground level car park, and they're going to put a new building, 2-story building with low ground car parking in it. And the client was very conscientious. They wanted to de-risk the site as much as possible. They didn't want any unknowns, as it were. So when they came to RSK, we recommended a PAS128 M3P GPR utility survey. And the M3P states that we'd undertake GPR across grids of 1 meter intervals. And we also undertook a topographical survey on which to overlay our results. So here's the topographical survey, and we can use that to then identify where those service covers are. So during the Type B survey, we'd go out and be able to target them and lift them. So as part of the utility detection survey, we identify and lift service covers, employing electromagnetic location techniques to detect and map metallic and electrical services, usually with the clips and the clamps there. We can also trace open ducts and pipes, such as drainage pipes, using flexi-trace cables and so on. We can also use those for fiber optic cable ducts as well. Then we record the EML detections topographically and transpose this onto our AutoCAD drawing, our CAD drawing. And where we've opened up the covers and measured those services directly, those are a verification survey. It's a quality level A because the accuracies are so high. So this gives us some information about the site. Here's the EML information onto this. It looks a pretty good survey. There's a lot of information there. But EML, we know, cannot detect all services. It can't detect non-metallic services. It can't detect isolated buried obstructions. So as per PAS128, we would also employ GPR techniques across this area. Full coverage of each site should be completed with GPR in orthogonal directions. Therefore, when we go to a site, our surveyors would look at the site and then try and lay out the GPR grids to cover as much of the area as possible using as fewer grids as possible. And this allows greater continuity with data collection, but it also aids with the interpretation. So here are our grid lines, those green lines that we used. So as you can see, we're covering as much of the area as possible, even though it's an odd shaped area, using as fewer lines as possible. And if we zoom into this area, here are the scans that we collected. First of all, in one direction, and then in the other direction. And when you put them both together, you can actually see the density of coverage is really high. But if this is just a car park and a bit of soft landscaping around the outside, what's the benefit of doing this? Is this not just overkill? Why are we post-processing that data? Well, in order to do so, we can look at the Gpr data itself. So here's some of the example Gpr data from this survey, where the Gpr data provides clear, consistent responses in the radargrams along a grid. For pipes and cables, these manifest themselves as hyperbole, and we can pick these responses, the peaks of the hyperbole, in our interpretation software, and therefore we can apply an accurate depth to them. And where they correspond to services detected by the EML survey, we can give them a high quality level, B1P, so the client knows the accuracy and the quality of the data. So here we've traced in the EML survey a metallic water pipe and an electric cable, probably in a duct. And these are corresponded, the Gpr data has corresponded to those traces. Now, we do have areas where there are consistent responses, but we've got no detections in the EML survey corresponding to them. There were also no records on them from statutory service plans or as-built records. But we can mark these on the drawings as Gpr detected linear features, providing the client with useful, accurate information that helps them identify potential hazards. In some areas, there's no hyperbole as such to actually identify representing services. In these radargrams, again, along the same part of a grid, we've just got some strong amplitude flat reflectors. They're obviously different from the surrounding ground. There's a higher amplitude, they're consistent in their response, so we can still pick their extents, and we have their depths. And again, we can map these onto our drawings. And when we look to as-built drawings supplied to us by the client, and where these features plotted, it appears that they most likely represent these soakaway systems that were built underneath the car park to take all the surface water drainage. Then we have areas where we've got no real discernible targets. Here we've got some radargrams, we've got an area of stronger amplitude response. This may represent made ground, but we don't know, but we still pick their extents and the depths of this area. And again, we've got that information and we can overlay it onto the drawing, providing the client with some information about that area. Now, that made ground that we just saw, when looking where this data was collected from on site, nothing was present on the surface on that landscaped area or from the EML tracing survey. When we pick the data, we can export those picks with an accurate position and depth. And on this occasion, we mark it as disturbed or made ground, and that's what that brown hatching is that you can see there. So there's clearly something there. Upon interpretation of that, we can see something that's clearly there forming this sort of rounded pattern. And again, it provides the client with useful information. As it turns out, when we look back on historical aerial images of the site and information, we saw this data line up with a tarmac path that was there prior to the development for the open car park. Now, this path was most likely ripped up and overlain by soft landscaping, but we saw the remnants of this in the Gpr data. And as well as this, we also detected redundant service routes, such as the electric cable ducts for the lighting bollards that used to line that path as well. So instead of the client just digging up an area and suddenly coming across a duct with no information about it, because it couldn't have been picked up on the EML survey, they now are aware that there's something there and can get ready for it. So what information has that given to the cover lifting and EML survey? Well, there's the EML survey. When we add the Gpr data, you can see it's clearly added a lot of information, as well as confidence in the already traced services through the EML survey, The GPR has added linear features and anomalies that could not possibly be identified without post-processing that data. Now, this final drawing helped the client de-risk the site as much as possible with regard to buried services and obstructions. They could target those unknown GPR features as they have confidence in the results. And our results also helped save time and therefore money that could have been lost through stand downs or service strikes. This is another case study. This is of an area in central London, and on the left is a utility survey that was completed before PAS128 back in 2005. I don't know who the company was that produced it, but it supposedly did use GPR. Those pink lines that you can see there actually represent GPR targets that survey produced. And then on the right, you see our PAS128 GPR utility survey that RSK completed in 2016. And you can see how much more information can be provided with a thorough survey. We've got the extent of the reinforced concrete, we've got buried anomalies, we've got non-metallic services in there. And then outside of the site, you can actually see on the roads around the site, the density of the services that are actually on some of the streets in busy urban areas. If we look a little more closely at one of those, here's some extracts from this survey where we've applied quality levels to different segments of the same traced utility. So in one place, we've been able to identify an electric cable. We've traced it with EML and identified it in the GPR. And the quality and the accuracy of the GPR data has allowed us to assign the highest B1P quality level. Whereas further along, the same electric trace, the GPR data wasn't as clear, wasn't as concise, and we could only provide a lower quality level of B2P. So the client then knows that the depth there is there or thereabouts, but we've got additional sort of quality constraints to work within. So what is PAS128 providing? It's providing the transparency of the work done and the retention of the survey data and records. Currently in PAS128, although it's not a requirement, it is recommended as best practice for all GPR data, all data, to be recorded. Now, this is automatically done for post-process surveys. It is currently optional for other detection surveys, unless the client chooses to make it a requirement. Now, as I mentioned, a new update of PAS128 is due out later this year. One of the proposed changes is that it is made mandatory for all GPR data to be recorded. But what does that mean for clients? Well, it means it gives accountability of the results. Now the practitioner must specify and stand by the accuracy of the results so the client has a comeback. So if something has been missed or is inaccurate, the practitioner can't hide behind such statements as radar was not conducive in this area. It also means that there's a record of the work done, and data can then be requested to be reviewed either by the client or a third party and audited at any time. And with the update of PAS128, there is this new appendix for service location and avoidance, which supports breaking ground, such as with site investigation, thereby tying it in with HSG 47. Now, HSG 47 is the HSE document which provides best practice with regards avoiding danger from buried services when breaking ground. The safe system of work, which HSG 47 states should be employed, shows the various PAS128 survey types applying directly. Now, this is also something RSK that we've employed in our own guidance. So here, this is the RSK safe system of work for when undertaking breaking ground during site investigations. And with regards to buried service avoidance, what we've produced here satisfies HSG 47. It implements PAS128 and allows for the practical realities that we encounter on site for the works to be commercially viable. Now, if there are any deviations from this safe system of work, we've got an approval process that is robust. It needs to be satisfied, recorded, and signed off by a competent director if we deviate from that at all. And the PAS128 elements require in this that we have a full set of up-to-date service record drawings. The site reconnaissance should be completed with that full set of record drawings. A utility detection survey is completed with 2 or more geophysical techniques, which includes cover lifting and identification of services, and that all data is recorded and retained. So the hand dug pits as well at the end are there. So we do hand dug pits or vacuum excavation to 1.2, and that's designed as the final part of our safe system of work to uncover any other services that were undetectable during the detection surveys. So again, satisfying a QLA survey. But the immediate information required for service clearance to take place on that day or the following days for the purposes of breaking ground is still available. The sketch that SafeGround produce, that we ask our approved subcontractors to produce, is an accurate representation of what is detected and what is shown on the ground surface. On it, we can see that it also details things that have been found, but also what hasn't been detected, those remaining risks, so that when a sketch is produced to the lead site investigation engineer, they know that when looking at this sketch, what those remaining risks are. So at the top there, you can see probably gas in the green line, gas brackets are, which shows there's a gas pipe shown on records that is in the vicinity of this location, but it hasn't positively been identified. So when the hand dug pit to 1.2 meters is undertaken, the site investigation team know there's the possibility that that undetected gas may be present, as well as other undetected services. So this sketch helps form part of the permit to dig system. It provides an auditable trail to show the safe system of work has been undertaken. If there was no sketch, it was as if someone has come along, sprayed a dot on the floor and told us, yeah, you can dig there. And then if those service avoidance teams move away and we dig down and we have a service strike, we've got no real evidence that a GPR utility survey has been done. So as part of that permit to dig system, the sketch is part of that sign off before we break ground. And this is also the reason we record the GPR data. It also means we can review it to provide information for the site. If there's any issues when they're undertaking this, if they've come across a service, we can immediately review that information and suggest reasons, either if something was missed or if the ground conditions weren't great and we definitely weren't seeing that. And that also helps with our training as well. And all elements of the safe system of work is designed to reduce the risk of service strikes as much as is reasonably practicable. And since the implementation and refining of that guidance, there's been a decrease in the number of service strikes that we've had in RSK. Now, these figures are taken from between 2012 to 2017, and these are normalized to account for the rapid increase we had in our ground investigation activity. Actual numbers of incidents dropped from 11 in 2012, when we had 494 staff, to only 1 incident in 2017, when we had 840 staff. Currently, with the growth in the RSK group, we're responsible for the digging of nearly a quarter of all holes in the UK. So this is a trend that we clearly intend to continue as much as possible. So that's just the buried service detection side of geophysics. This is just an example of some of the other geophysics that we undertake in the environments and different sectors that we work in. We have a geophysical handbook link on our website, which details the other geophysical techniques we do and their applications. Now, with regard to buried objects on site, I'll now just touch upon PAS128 and see how that differs from PAS128. So PAS128 is the UK code of practice for ground investigations. So if you want to commission a geophysical survey, PAS128 sets out how to go about requesting one. They'll be completed to a standard. It details how geophysical surveys are designed to detect buried features of interest or provide reconnaissance across a whole site. All detected anomalies are required to be interpreted and reported in full to the client. This is different from PAS128, which only states that you should inform the client if something else is seen in the data, but you aren't necessarily required to provide details about it. Chapter 5 details how to go about obtaining a geophysical investigation and what sort of deliverable you're expected to receive. It clearly states that you need to take advice from a qualified expert, the sort of information, what sort of information is required in order to provide an accurate quotation, and that you are able to compare tender returns like for like. And it also states that practitioners should have formal qualifications and that deliverables should be signed off by accredited professionals. The deliverables should provide clarity on what you do and don't know following the survey. It will be clear to understand how much effort was put into obtaining the data and the various steps through processing, interpretation to the final deliverable. And there is recourse if the survey was not completed to a satisfactory standard. The similarities with PAS are there, but with a noticeable difference that you should employ qualified geophysicists that are chartered. So with regards to PAS itself, since its release in 2014, it's had reasonably good take-up. Lots of clients know to ask for a PAS128 survey, and it does help promote best practice that lots of practitioners have taken up. And it requires those practitioners to stand by those results, which allows the client to have protection in the case of poor performance. The update that is coming out later this year, the new revision aims to provide the client with confidence in the quality and the accuracy of the surveys. It aims to be a bit more user-friendly. It's got a client guide in a new appendix, which helps explain the various steps as clearly as possible. And there is this new appendix on PAS128 surveys for site investigations when breaking ground. And it requires records and data to be kept, guaranteeing an auditable trail. So that concludes my talk. Thank you very much for your time. I'll just turn my webcam back on. We'll go to Mark and see if we've had any questions.
Thank you, Gerwyn. Yeah, I'm sure that was a very useful talk for anyone either instructing or undertaking ground investigation work. And yes, we've got a few questions in for you. So, but if we've still got time, so if anyone has any questions they still want to ask, just drop them on and we'll add them on to the end. So first off, how long do statutory undertakers drawings last before they go out of date?
Well, typically, statutory undertakers update their drawings quarterly, so 3 months, 90 days. After that, it's considered out of date. So really, we should get an updated set of service plans. Now, if a client has PC control of that land and knows full well that nothing else has gone in, we can use those most recent set of drawings as long as the client has confirmed to us that no other works has taken place. But as a general rule, 3 months, 90 days, the plans are in date.
Okay. How quickly can you turn around post-processing information, as we can be needing clearances as soon as possible ahead of drilling works?
Well, for clearances themselves, that's where we actually use the on-site Gpr data. We get that real-time information from Gpr, we spray it on the ground, we interpret it as best as possible, we produce that sketch, which is then used as part of the permit to dig system. Now, if you're doing a post-process survey, the post-processing can take a bit longer to turn around before you can get out on site. So usually would say if you've got a day on site, it's going to be 1 or 2 days of in-depth interpretation and then production of a CAD drawing. Typically, we do tend to say 5 to 10 days from from the beginning to an end of from the end of site works to producing the deliverables. So those sort of timescales.
Okay. How many geolocations can sensibly be covered in a day?
It depends on the site. So in a busy urban area, I remember when we were doing a big site investigation in Brent Cross, I cleared 2 locations in a day, and that's all. And that was purely because it was in an area that was absolutely riddled with services, service covers, had to lift it all, traced it, mark it down on the ground, try and work out if all of the records corresponded to what I found on site. So it took a long time just to do 2. Other times we've been out on greenfield, rural sites, no history of development, no services shown on statutory record plans, and it can be done much quicker. And we've got some machines in the SafeGround team that can do upwards of 20 odd locations in a day. So yeah, it really does depend on the environment.
That's a good idea to ask you guys really when planning ground investigation works, about what the type of site is and how many you can get done.
We've got people who, you know, we've been doing this for a very long time. We can have a look at that information really quickly and give you a good sort of assessment of how long we think we can do so many locations.
Okay, great. What format are the deliverable in? Is it in 3D?
Yeah, well, we can deliver it in 2D. We can deliver it as a 3D model. We deliver it generally in AutoCAD. We have been asked to do bits and pieces in MicroStation, which we can convert to. We can convert to some GIS as well to feed into that. The AutoCAD 3D drawings, most of the Gpr utility surveys that we do, the vast majority are going to be outside. So they go up to building edge. So they can feed into BIM modeling, but it basically generally then stops at the building edge.
Okay. And the RSK safe system of work that you outlined, do we require hand dug inspection pits in addition to geophysics techniques, even when those services are suggested?
It will all come down to the assessment of the risk on site. I would say that, you know, even in fields, big open farmers' fields, we've come across services that the farmer put in, you know, tens of years ago, and no one knew about. There's never ever going to be a record for it. If you have a geophysical investigation, a GPR utility survey, it cannot guarantee you 100% detection of all services. There's always going to be something that is either too small, non-metallic, no record of them that may be found. So it depends on the attitude to risk, and as part of our safe system of work, that should be part of the discussion between a competent director and the project manager.
Okay. I guess sort of as a follow-up, are there any instances when it's going to be difficult to use geophysical techniques, and what would you advise in their place?
The GPR is the most versatile GPR technique. It allows us to have that real-time evaluation of data combined with the EML tracing, and that information can be put on the ground. Other geophysical techniques do actually require the data to be then processed, and we don't get an immediate answer for those other geophysical techniques. Now, GPR does have its limitations. If you've got very dense area of reinforced concrete, it may not be able to pass the signal beneath that reinforcing, and it may even mask. If we can get a signal through, it may mask or scatter the signal from the buried surfaces that might be in there. And sort of salt water is terrible for GPR data. So if you've got sort of a really saline water table, then we'd have real problems with that. But again, using the sort of a combination of the EML and the GPR, that gives us the best chance of getting some real live data there and then. And unless you try it, you don't know if it will work or not. So our attitude is always, let's give it a go first.
Okay. Couple of questions on this subject. What's the minimum competency or qualifications the surveyor requires when undertaking service clearance you might be looking for if you're commissioning work?
Yeah, so, well, as I said, with PAS128 surveys, there's no minimum requirement to have any sort of accreditation. There are various qualifications that can be achieved. There's a ProQual Level 3 certificate, Level 4 and 5 diplomas in utility mapping to become an accredited utility mapping surveyor. The majority of the staff we employ in Geophysics and SafeGround are degree educated, and they'll be working towards chartership. And SafeGround staff will also be working towards those Level 3 and Level 5 accreditations. So it's worth checking to see what your company or what the company is offering in terms of their qualifications, but there is no actual specification of what someone should have as yet.
Okay. Should my marked out utilities always be recorded with satellite and or total station and turned into a drawing?
I think for the commercial realities with site investigation, I don't think that's always feasible, but we do want to have an auditable trail. So that's where the sketch comes in, and if we can get GPS coordinates of that particular location, then we've got a full auditable trail of where that data has come from. If you're working on these big infrastructure projects, certainly HS2, and certainly the work that we've done with regards the development of power stations, all of that data, even for clearances of boreholes, everything has had to be topographically mapped and put on a drawing as part of that service clearance.
Okay. I think this one may have come from a client, but when tracing services on a greenfield parcel of land, would you start tracing the boundary perimeter first, then work into the site once abnormals were found? The questioner was thinking of costs from a client perspective.
Yeah, no, well, that's it. And you've got a big greenfield piece of land, no history of services on it, no history of development on it. First of all, we look at the statutory service plans. Mainline services will be recorded. So if there's anything crossing that land, they'll show up on those records. Now, if there's nothing there, then we would do a perimeter survey, certainly with the EML, and doing a grid across the entire field or on the localized locations for the site investigation works. And GPR, you'd have to take an assessment really. If you go and do a perimeter survey, it depends on the size of the field. You could be walking quite a way, or it might be better to do those isolated GPR points. But again, we try and look at it, what is the most commercially viable that still keeps those risks of hitting services as low as possible.
It's probably worth mentioning, you know, with CDM and clients needing to provide resources for these sorts of things, not wanting to spend the money isn't a terribly good defense if you hit something and someone's injured.
No, absolutely, absolutely. And, you know, we've always sort of maintained that. The good thing about working with SafeGround and having all this internal work for geosciences, for structural soils, all of the RSK companies is that you work with these people. You want these people to go home safely at the end of the day. And that's always been our key concern. So there may be the odd grumble about the cost of it, but that's always our major concern.
Absolutely. Well, I think we've come to the end of the questions, Gerwyn, so thank you very much. So I'd just like to thank everybody for attending this afternoon. Next month's talk is going to be on economic design of ground investigations. So invites will be coming out shortly. Thank you very much. Okay, have a good day.
Thank you.